Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 9, Lesson 6, Triangles and Their Angles. This is the last lesson in our introductory unit on geometry in Math 7. And what we're going to be doing today is we're going to be exploring the three angles, i.e. triangle, that are within a triangle. Right? And seeing if there's any special relationship amongst the three angles that are contained in a triangle. So let's get into that right away in the first exercise. Now, one of the things you're going to need for this exercise, or for this lesson certainly, at least right away, is going to be a protractor in order to measure some angles. Now, triangles are three-sided shapes where each side is a line segment. Pairs of these line segments then create three angles within a triangle. These three angles have a very important property. Now, before we move on, I just want to clarify something, right? We defined an angle as being two rays, right, that share a common vertex point. And all of a sudden, I'm going to say, right, let's say we just talk about triangle ABC here. All of a sudden, I'm going to tell you, well, wait a second, this is an angle right here, angle A, or angle CAB. What's one thing that's nice is we can go back and use the one-letter naming system, at least today in these particular problems, because there is only one angle A, only one angle B, only one angle C, etc. Now again, if you're bothered by the fact that these aren't rays, that they're only line segments, remember a line segment is a part of a ray, right? I can extend ray AC as far as I want, I can extend ray AB as far as I want, and I still can talk about what it would take to rotate, let's say, ray AB so that it lied on top of ray AC. So I hope that nobody is thrown off by the fact that you can still have angles even if you have line segments instead of rays. I hope. Anyhow, let's take a look at exercise number 1. Two triangles are shown below, triangle ABC and triangle DEF. For both triangles, use a protractor to measure each of its angles. Place the angle measurement in the triangle. Then find the sum of the angles of each triangle. Now, this is going to be a little bit easier for you than it is for me because I can't turn my sheet of paper. I actually have to turn my protractor. You can turn your sheet of paper. But let's do triangle ABC together. So the easiest angle for me to measure will be measuring angle A. So I'm going to put vertex A right there at the center of my protractor. I'm going to make it a little, and then I'm going to rotate it apparently. I'm going to make it a little bit bigger so you can see it, right? And hopefully what you see is that the measure of angle A is 30 degrees. I'm going to be using this scale on the inside because I'm measuring from here up. So 30-degree angle for angle A. Let me shrink this thing down a little bit and kind of rotate it apparently again. So I'm just going to write in 30 degrees there. Now, angle B is also pretty easy for me to measure because I don't have to do any sort of rotation or anything like that. And it should be pretty obvious right away that the measure of angle B is one of our favorite angles. It's 90 degrees, right? There's that nice right angle, that nice quarter turn. So I'm just going to do this, move this out of the way, 90 degrees. Now finally, the one that's going to be hard for me, but it should be relatively easy for you, you would just want to turn your paper. For me, I'm going to bring this in, and I'm going to have to, I'm going to have to rotate my compass down like this. All right, maybe move this a little bit more. I don't quite have it at the vertex there. Now this is going to be a little bit hard for you to see. All right, so let's go back to me. I'm now measuring up like this, okay? And although it might be hard for you to see on the board, that's a 60-degree angle. A 60-degree angle. So we measure this back, put this down here, and I've got a 60-degree angle. All right, so that's easy enough. I've got a 30-degree angle, a 60-degree angle, a 90-degree angle. Now I want to add them all together. So maybe I come down here, 90 plus 30 plus 60, 0 plus 0 plus 0 is 0, 6 and 3 is 9, plus another 9 is 8. So comes out to being a nice 180 degrees. All right, great. So what I'd like you to do is I'd like you to take your protractor and measure the three angles in triangle DEF and also find their sum. Pause the video now and take a few minutes to do this. try to make sure that you measure those angles accurately. They do come out nice in this triangle, okay? I haven't given you any like 53-degree angles or anything like that. So pause the video now and find the measure of those three angles. All right, well, we won't maybe do all three of them, but let's find the measure of angle D together really quick. So I'm going to go like this. All right. Again, it's pretty easy for you to see that the measure of angle D is going to be measured this way. It's going to be 40 degrees. All right. Hopefully you also found that the measure of angle F was 40 degrees, and then the one that's quite challenging for me is E, but that's 100 degrees. All right. So if I add all those up, 100 plus 40 plus 40, I get 0, 8, 1, and I get 180 degrees again. Huh. All right, so these two very different looking triangles, right? 30, 60, 90, 40, 40, 100, right? In both cases, when I add the three angles together, I get 180 degrees. And possibly one of the most remarkable properties in all of geometry is that this is always true. The sum of the three angle measures of any triangle, big, small, obtuse, right, acute, equilateral, isosceles, green, red, blue, it doesn't matter. Every triangle, when you add up the measures of the three angles, they sum to be 180 degrees. It is a remarkable thing. And in Math 8, you're going to look a lot more at why that is. And in high school geometry, you will have hard proof evidence. You will actually prove that the sum of the three angles of any triangle will always equal 180. In Math 7, we're now going to take it as a fact. Fact. If you add up the three angles of a triangle, they equal 180. And let's take a look at that one more time with a protractor in exercise number 2. Triangle ABC is plotted below. A. Find the measure of angle A and angle B, state them below. And then we're also going to find their sum. All right? So what I'd like you to do is take your protractor just one more time in this lesson, find the measure of angle A, find the measure of angle B, and then find their sum. By the way, their sum won't be 180 because we're just finding the measure of two of the three angles, but we can still find their sum. Pause the video now and go ahead and do that. All right, let's do it. So, measure of angle A, that's going to be fairly simple. I'm just going to bring this over here. I need to make this compass quite a bit bigger, but hopefully what you can see is that the measure of angle A is going to be 30 degrees, right? 30 degrees there. So let's get rid of that. We'll put 30 degrees. Now let's come over and find the measure of angle B, my nice obtuse angle, right? Definitely an angle that's bigger than 90 degrees. And in fact, maybe try to make it a little bit bigger for you to see. All right, hopefully what you can see is that the measure of angle B is 100 degrees. 100-degree angle for the measure of angle B. All right, so actually adding them together is going to be quite easy, right? Measure of angle A plus measure of angle B is 130 degrees. Now, all right, letter B. Predict the measure of angle C based on A, then check with your protractor. All right, here's what I mean by that, right? We know that the sum of the three angles of any triangle are equal to 180 degrees. I've measured A and B, 30 and 100, and I've summed them to be 130. So how much is left for the final angle? Well, since the three angles must add up to 180, right? Measure of A plus measure of B plus measure of C equals 180, right? If this is equal to 130, right, then the measure of angle C should be 180 minus 130. It's got to be 50, right? It's got to be 50 degrees. But the cool thing is we can check this. Pause the video now, take your protractor, and check to see if the measure of angle C is 50 degrees. All right, well, let me see if I can do it. All right, I'm going to bring this protractor up. A little bit tricky. Oh, come on. At least I should be able to get it on the vertex. All right, we're gonna rotate it. Again, trying to just get the vertex at the center. And now let me stretch it out so that you can really see it. Really see it. Let's come back to me just for a moment. And hopefully you can see, right, with this pointing down the 0 line, right, this is kind of cool. I can actually rotate this thing up like that, and you can actually see, well, it puts the measure of it way up here, but it shows me the measure of that angle as 50 degrees. All right, kind of a cool tool that we can use here. All right, but again, what is the moral of that story? The moral of that story is if I know 2 of the 3 angles of a triangle, I can add them together, subtract from 180, and that will tell me the 3rd angle, right? And many, many geometry problems are set up that way, where possibly you know 2 of the angles, or somehow you can find 2 of the angles, and because of that, you can find the 3rd angle. Let's take a look at that scenario in exercise number 3. In triangle MNP, the measure of angle M equals 40 degrees, and the measures of angle N and angle P are equal. Find their common measure and show how you arrived at your answer. All right, so here I say, well, I'm going to give you 2 angles and you have to find the 3rd one, and then I give you 1 angle and I ask you to find the other 2. Now, generally speaking, that's impossible, right? If I give you only 1 of the angles, all I know is that the other 2 plus that one must be equal to 180. But in this problem, I told you a little bit more, which is the measure of angle P and the measure of angle N are equal, all right? Pause the video now and see if you can figure out what their measures are. All right, well, in a triangle, I only have 180 degrees to play around with, right? So the first thing I might do is say, well, if I take that 180 degrees and I subtract off the angle I know, then that leaves me with 140 degrees. Now that 140 degrees must be split up amongst the 2 other angles. If I didn't know that they were equal, well then all bets would be off. I might have to set up some kind of different equation. But I know that the 2 are equal, and therefore that 140 degrees must be divided up evenly amongst the 2 of them, and that means each one of them has to be 70 degrees. All right? 70 plus 40 gives me 180. All right, let's keep using this fact. All the angles add up to 180 degrees. Exercise number 4. In triangle EFG shown below, the measure of angle F is 58 degrees, the measure of angle G is 2x minus 8, the measure of angle E is 3x plus 5. Algebraically, find the value of x. All right, in the last lesson, all we did was set up equations that had relationships in them between angles, and we used those then to solve for a variable and to sort of like figure out other things geometrically. Here, all I want you to do is set up an equation and solve it for the value of x. See if you can use what we learned today to do that. Well, what I know is that the measure of these 3 angles must add up to 180, right? I know that the measure of angle F plus the measure of angle G plus the measure of angle E must be 180. That is true in any triangle. So I can say 58 plus 2x minus 8 plus 3x plus 5 equals 180. Now, I've got some work to do, right? Because I've really got to clean up the left-hand side, collect like terms, things like that. So I might rearrange that left-hand side as 2x plus 3x plus 58 plus 5 minus 8 equals 180, right? These 2 combine to be 5x. These 2 would combine to be 63. Then I would have to subtract 8. 63 minus 8 is 55, and I apologize for that, but I now have 5x plus 55 is equal to 180. All right, now I have a classic 2-step equation. I'm going to subtract 55 from both sides. That's going to give me 5x is equal to 125. I'm going to divide both sides by 5, and x is equal to 25. And that's it, right? Prior to this lesson, we wouldn't have had any way to really relate these three angles together. But the three angles of any triangle always have this beautiful relationship. Their sum is equal to 180 degrees. Let's see how we can use this in one final problem. Exercise number 5. Actually, this has got a bunch of problems within it. All triangles have angle measures that sum to 180 degrees. Use this fact to answer each of the following questions. Letter A. What is 1/2 of 180? What kind of angle is this? Illustrate. All right, well, first off, letter A has nothing to do with triangles. Not yet, at least. This should be pretty easy. Let's talk about this together. What is 1/2 of 180 degrees? That's 90 degrees, right? What kind of angle is that? That's a right angle, right? And you can really kind of illustrate this using a straight angle, right? So angle ABC is a straight angle, and there's that 180 degree rotation, right? Half of it would be 90 degrees. Literally, you'd get a 90 degree angle here and a 90 degree angle here. Now for the part that actually relates to triangles, letter B. Why can't a triangle have two right angles? Oh, this is a nice question. Pause the video now and see if you can figure out why a triangle could never have two right angles. All right, well, this is really cool. Think about this for a moment. Let's say it did have two right angles, right? Well, you'd have 90 plus 90 plus some other angle, right? That's what you'd have as like the sum of the three angles. Except the problem is the 90 and the 90 would be equal to 180, and it wouldn't leave anything for the final angle, right? If there were two right angles, if there were two right angles, the third angle would measure 0. And that's not an angle anymore, right? A 0 degree angle literally is this. Right, it's two rays that lie on top of each other. That's no longer an angle. I don't even know what that triangle would look like, right? It just doesn't even make any sense. Now, one last little piece, which is kind of cool. When you were a little kid, you might have been 6 months old or even, you likely had a relative, or a babysitter or something that had you look at picture books, right? This is a picture of a square. This is a picture of a circle. This is a picture of a triangle. And whenever they showed you a picture of a triangle, they likely showed you what's known as an equilateral triangle. Now, an equilateral triangle technically is a triangle where all three sides have the same length. But because all three sides have the same length, all the angles also have the same measurement. The question is, what measurement? So what are all three angles equal to? Not their sum, we know that's equal to 180, but what is each angle equal to in an equilateral triangle where all the angles are the same measure? Well, we could set up an equation. We could be like x, x, and x, but at the end of the day, right? I mean, since they all sum to 180 degrees, and there are three of them, right? Then it means that each must measure 60 degrees, right? And just to verify that, as our last little piece in this lesson and in this unit, I can most certainly measure one of those angles, and hopefully what you see, 10, 20, 30, 40, 50, 60, is that indeed it's a 60 degree angle, right? Not just it's 60, this is 60, and this is 60. And you'll use that fact quite a bit in math and in future math courses, right? If you have an equilateral triangle, immediately you know all three angles are equal to 60 degrees. All right, let's wrap this lesson up. So what did we really see today? Well, we saw these objects called triangles, which you've been seeing for years and years. I get that. And you've actually been seeing angles for a few years now as well. The key, though, that we saw that was new today was that all three angles in a triangle, no matter what type of triangle it is, sum to be 180 degrees. We oftentimes have to use that relationship to solve a variety of different geometry problems. All right, and you'll certainly see that going forward in your math courses. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.